Yep, good morning everyone. So yes, today we learned about some events, element state events we learned. So in event binding, so we discussed about mouse events and keyboard events and button events. So clipboard events, right. So element state events, we discussed these. So these are different types of events we learned in event driven. Clipboard events, on cut, copy paste, button events means click, double click, right click. These are button events. Element state events means on blur, on change and done. So have you tried those examples? Huh? Yesterday we learned about some EMI calculator we designed on example. Into classroom group, I will share some tasks also related to what topics we are learning. In addition to what you are learning in class, those tasks you have to try. Means in interviews, how they give the tasks, how to handle them. I will give you some exercises. You need to practice them. So we learned about these events up to element state. Element state, on change, on blur, on focus, these all comes under element state. Now we need to know another important timer events. So we need to understand timer events. So many questions are asked related to timer events in real world. So what are these timer events and how to handle them? We'll see one example. Already in JavaScript, what timer events you learned, same. Here the usage is little different. What are the timer events you learned in JavaScript? Set timeout, set timeout, clear timeout, and set interval, clear interval. These are the timer events you learned. In JavaScript, these timer events are important. So what is purpose of these events? How to use these events, we will see. As I told you in React.js interviews, one of the main concept for interview is this timer events related. So events also, some major questions are asked, like we learned event bubbling and all. Timer related events, what they are, how they work, we will see. So first, one example we will create here. I will add a simple component, timeout demo .jsx. I am creating one component. This is timeout demo is the component. So in this component, we are having a button. Let's keep this as text center also. Here show messages. Okay. And we have some paragraph. So we are designing some messages here. Let's keep this timeout demo in the startup. Timeout demo is in the startup. Okay. Let's start this application. Now, in this timeout demo, we will create a constant, some message. Set message is equal to use state. It's a string. So we are creating one state for storing messages. And we have functions. Message 1 and it will set message as hello. We have another function message 2. It will set message as so how are you. So we have another message 3. Set message is welcome to React. Okay, we have 3 functions to execute the message 1, 2 and 3. These messages I want to display inside this paragraph. So for this paragraph, I will keep the message. On this button click, I want to show the messages. So here we have margin Y4. On click, it should use some handle show click. We don't have a function. We will create a function handle show click. This function should execute. And what it has to do, call all these messages, message 1, message 2 and message 3. On button click, 3 messages I need to call. Message 1, message 2 and message 3. These 3 functions are executed. What these functions are doing, whatever message is there, they are storing in that MSG, set messages. So now we will go to the design. Yep. In this design, when user clicks show messages, those messages are displayed below. But it is showing only the last message. That means the message that is present in function 3. Actually, we have 3 messages. Message 1, 2 and 3. 3 messages are present. So in these 3 messages, it is showing only last. Now, what happened to message 1 and message 2? The question is, have they printed? Message 1, message 2, have they printed on screen? Yes, they have printed. They printed, but our eye cannot catch them because it is so fast that we cannot catch the speed. It printed. It printed the first message, after the second, after the third. You see, when I click on show messages, it printed all 3 messages, but it's so fast that you can't see them. So this is the problem with electronic devices. You are learning about computer programming, electronic devices. Here one major issue is you are not using typewriter. You are using a keyboard. So what is the problem with keyboard is, generally you see, you people say, I am typing some message. Usually keyboards don't type. So typing is a wrong word for computer. Computers don't type. Keyboard don't type. Do you know? Keyboards don't type. Typewriter types. What keyboard do is, actually, what keyboard do is, generally, keyboards usually, they don't type, they key in. They key in. Keyboards don't type, they key in. Typing is done only with the typewriter, not keyboards. So keyboards use key in mechanism. That means in typewriter, when you hold a key, then it will type once. After that, it will stop. But keyboard is not like that. When I hold down a key, what will happen? When I hold down a key, it is continuously typing now. That is not typing. That is keying in. We call this as keying in. This is not typing. So keyboards never type. Keyboards usually key in. In your mobile keyboard, you hold down a key. Will it repeat? Doubt? Will it repeat? It will not repeat. That's the reason it shows typing message. It says typing message. Computers don't type. They key in actually. So they don't type. Type means you hold down, once executes, after that it stops. Key in means it continues. Now what is problem in this concept is, suppose you are using a TV remote. When you are using a TV remote, what happens is volume up, volume down buttons are there. You press the volume up button and hold down the button. Just release it little late. Then the volume will go several points. Am I right? Actually, when you hold up, volume up, it directly goes to 100. When you press volume down, it directly comes to 0. It is so fast that you can't control it. That's the reason the people who designed the program for that volume control in remote control, electronic devices programming, they use a mechanism called, do you know what is that mechanism called as? You hold down a key, it immediately executes one after another. That is called bounce. In electronics devices, we call this as bouncing. Anybody who belongs to electrical engineering, they come across with this word bounce. No? Are there electrical engineers, electronic engineers are here? Huh? Our genius people. Huh? Huh? Because what is genius about our electronic engineers is they can't repair their fan at their home. And a 4 years electrical engineering diploma. After all, they cannot repair a fan at their home. Huh? That is the capacity of our engineers. Huh? So if you have done some electrical engineering programming and all, you know the mechanism of bounce. Bouncing is a mechanism where it will not wait for any task to finish, immediately it will perform another. How do we control this is, it is called debounce. In computer programming, in electrical devices programming, we have to implement a mechanism called debounce. Every technology have to do. whether it is Java, C++, .NET, any programming language, have to implement the mechanism of debounce. What is debounce is when a user executes the task, it should not immediately execute. It should wait for some time. Usually user hold down a key, but even he hold down a key, the next task must be released slowly, one after another. Some time should be taken. If we don't design debounce, every application in software fails. You can't handle applications. Every software application in the world, web to mobile, every application have to implement the mechanism called debounce. Debounce is a mechanism where a task is delayed by some time. User will give the task, but it is not immediately performed. It will wait, it will lock the task for some time and it releases. This mechanism is called as debounce. And in interviews, it's a very popular question. What is debouncing in computing technology? And how you control this debouncing? How we handle this debounce? So now what is the problem in our situation is when I click show messages, it have a bounce mechanism. All the messages executed so fast that I can't catch them. We can't see them. Then what we have to do, we have to implement the mechanism of what? Debounce. Debounce means actually what happens is in your application, generally we have 3 tasks designed. So the task 1, task 2 and task 3. We have 3 tasks designed. We have memory. We usually have the memory. And we have the process. So we generally have the memory and process. Now what happens is when you click the button, first basic thing is all these 3 tasks are loaded into memory. When you click the button, message 1, message 2, message 3, all these are loaded into memory. After that, they are released into process according to sequence. In the execution order, which message is first? Task 1. So it goes into process. Immediately, within a fraction of few milliseconds, the second task also goes into memory. And it is so fast in the process, it goes in so fast that you can't see it. You will feel like only last message is printed. Means from the memory, they are released into process with so fast that you can't see it. That's the reason you feel like it is overwritten. Actually, it is overwritten, but it has printed every message clearly. Only the point we are unable to see. So what we have to do now is when any task is sent into the process, we will lock these 2 tasks in the memory. We lock them. We don't release them immediately. We will make the first task to do its work. After that first task is finished, then we will release the second task. That means we will take some time. We load the task into memory. From the memory, we don't release the task immediately into process. We lock the task in the memory for some time. After that, it will release. Then user can easily watch one after another. Every message user can watch. That means we are making the tasks wait for some time in the memory so that they allow the other task in the process to perform. If you don't do that, one after another you send the tasks, that leads to lot of memory overload in process, and sometimes process will seize up. You know, when you are using your laptops and phones, suddenly they hang up sometimes. Why? Because sometimes you see, you people, what you do, you double click to open Visual Studio. It starts opening. It will take time. You will not wait. You will double click again, right? It is loading. You have to wait. If you give the task immediately to the process one after another, then what computer thinks? Some illiterate person is operating me. I will seize this and it will hang. That means why a computer hangs up? Because you don't know how to properly operate it. There is no defect in computer. There is no defect in your mobile, right? So the problem is in your operation. The tasks are given in such a way that you are not giving time for process. So we need to do that. We know that users don't have that knowledge and they don't have that patience. Even when user gives, we will make him wait. That means he will click immediately, but we will make him wait. How we can make him wait? By using a mechanism called debounce. Debounce is the mechanism. You will see everywhere. Suppose you are downloading songs, you are downloading videos. Have you observed when you are downloading songs? One song is being downloaded, you click another, it says please wait. Sometimes at a time it downloads 3. When you give fourth one will be in the queue. Am I right? That is debouncing. That mechanism is debouncing. There is no software technology in the world which works without debouncing. Every technology have to implement this debouncing. Java, .NET, these technologies will call them as multi-threading. They control this by using a concept called multi-threading. They call this mechanism as thread sleep. You know, heard about that? Same here. In JavaScript, we do that by using set timeout. We do that by using set timeout. So what set timeout can do is it can make the tasks inactive for some time and it can release the task into process after some time. That is the job of set timeout. That means how you can control that. That is the first thing. Let's see what is set timeout. We will implement that now. What is set timeout? It is a timer event used to handle debounce in application. It is a timer event used to handle debounce in application. So bounce is a mechanism where every task is released into process immediately from memory. Debounce allows to lock the task in memory for a specific duration. Allows to lock the task in memory for a specific duration. So that is debounce. So it makes the task inactive or sleep or log. You can use any word. Sometimes people call as sleep or lock or inactive. Anything is same. Now, how do we design that? How syntax works for set timeout in JavaScript? You already know. What is it? Set timeout requires a function. It executes a function and the interval you have to define. Set timeout uses a function and that function will be locked for specific duration. And for specific duration, the locking happens using interval. How much time it should be locked, we have to define using interval. So let's see how to handle this now. Just what we have to do is, in our example here, these three messages, now you understood what is happening. Three messages are loaded into memory. All are released into process one after another only, but very fast. We will do one thing. We will use set timeout. Using set timeout, we will call message 1. You just need to point the message function name. You can write the function here, or you can already have a function. You can just point towards the function. And interval. Interval is 3000 milliseconds. You know 3000 means 3 seconds. Now set timeout, another one. What is it? Message 2, and this is after 6000 milliseconds. And set timeout message 3, that is some 10,000 milliseconds. Remember, this means that all tasks are loaded into memory at a time. But after 3 seconds, first message will be released. After 6 seconds, second message will be released. That means what is the difference between first and second message? 3 seconds. So what does it means that these three messages are loaded into memory at a time, M1, M2 and M3. They need to be released into the process. What happens is, first 3 seconds this message will come. After 6 seconds this message. After 10 seconds this. That means the first message, second message time gap is 3 seconds. And the second and third message is 4 seconds. It doesn't mean that after 6 seconds, all are released into memory at a time. After that, within 10 seconds, all three will complete. Understood? Within 10 seconds, all three will complete. First one will be released in third second, second one released in the 6th second, and last one will be released in the 10th. Now you see here, when I run this time, I will click this button. Then first message will come. After 3 seconds, first message. After 3 seconds, second message. And after that, the third message will come. That is debounce. That is the reason in your TV remotes everywhere, when you hold down the volume, even you hold down, slowly increments. Slowly volume increments, like 1, 2, 3. Otherwise, it will jump directly 100. Again, jump directly to 0. Now we are locking them. We are executing slowly. We are executing slowly. So for example, if I put this like, so message, let's put this button with the class BTN and BTN primary and BI volume up I am using, okay. And this is just like, so nothing here, just volume up. I just used a volume up and just keep the messages like this. That means 10%, volume increase. Okay, after that 50% volume increase. After that 100% volume increase. Like this we are giving. Usually the same thing now. If I don't use timeout directly, it will give 100. Now when I click volume up, then what happens? It will be like 10% increase. After that 50% increase. After that then 100%. That's what they have to control with those buttons. This mechanism is called as what? Debounce. And important, when any task is loaded into memory, remember, these tasks are loaded into memory. These are the 3 tasks we are having. These tasks are loaded into memory. And from memory, they are released into process. Once they release into process, you can't cancel them. Any task released into process, there is no chance to cancel. You cannot cancel them. That's the reason you might have observed when you are doing some money payment in any app, you clicked pay button, amount debited, but on the screen it says disconnected. Have you observed? Have you faced it? That means on the screen it says disconnected, but amount deducted. How? If disconnected, how amount deducted? Question understood? Huh? Have you faced this? Right? If disconnected, why amount deducted? Because on the time when you click pay button, the task is released into process. It's finished actually. To give a response to you that it is finished, it takes some time. That means immediately the task is released. It will take some time to show you the response. And during the response time, it disconnected. Understood? During the response time, it disconnected. So the response comes to you saying that disconnected. But actually it is finished. Only the confirmation is pending. Confirmation is not shown. Another point, as I already told you, Axios also. Ajax methods we learn. Ajax methods you cannot cancel. Once it goes into the process, you cannot cancel them. Before it goes into process, you can cancel. That means this second task I want to cancel. The second task I want to cancel. I don't want it to go into process. Then when it is in the memory, then itself you can cancel. Once it is released, you can't cancel. Before it is released, you can cancel. How do we cancel any task from the memory? For that, clear timeout. We have to use clear timeout. What is the concept about clear timeout is? It is used to clear the task from memory before released into process. Before released into process. Clear the task from memory before it is released into process. Here, I am giving a simple point here. Actually, it requires a memory reference of task to clear from memory. It requires a memory reference of task to clear from memory. This is another important in React now. Actually, in JavaScript, what you do is, suppose if you want to remove any task from the memory which is loaded through timeout, in general JavaScript, what you do is, here, let's see. Actually, I want to remove the second task from memory. Means that 50% volume increase I want to remove from memory. If this one you want to remove from memory, see the point here. These three tasks are loaded into memory. That means this is your memory. And in the memory, we have task 1, message 1, message 2, and message 3. All three tasks are in the memory. Now tell me, in which memory reference message 2 is there? In which memory reference message 2 is there? There is no reference for it. All are in memory, but we are not sure in which reference which task is running, because memory is a heap. Na? You learned, right? Memory is a heap. Heap memory don't have an order. That means memory allocates in random. We don't know at which location message 1 is running, at which location message 2 is running. Then if you don't know, how you will cancel? Then in your JavaScript, generally what we do is, in JavaScript, people what they do is, they declare a variable. Variable is a memory location. Na? So M2 is a variable. Now what they do? They will assign M2 is equal to this message. That means now this message is loaded into memory, and the memory can be accessed with which name? M2, not message 2. Message 2 is the function name. It is not the memory of the function. It is the name of the function. It is not the memory of the function. The memory of the function is what? M2. Now it is okay. But this actually up to React 17, 16 version, people used to do the same. But now in React, we don't recommend this. Because earlier in React also people do this same. But in React, now we don't recommend this. Why? Because what is the purpose of a variable? To store some data. We can store some value. Where I can use this value? That means actually 2 points are there. I can use this value. I can use the value of variable in UI or in process. I can use this value in the user interface, or I can use in the process. User interface means presentation, so that user can watch it. Process means in the background we are using, we don't need to show it. So what is the point about process? Means some data is maintained in the backend which you don't need to see. You just need to use it. You need to use it, but you don't need to see it. If you declare in a variable, variables are always intended to show. Not just using in the process, they are also meant for showing. So that becomes slow. A variable is used in two ways. For process internally, another one is for showing in the UI. Now in React.js, they introduced a new concept. They say that if you want to use for process, then we have a solution for you. For process, for faster process, they designed another reference. They designed a memory reference. Actually, you are using use state. Na? In use state, you can store some value. This is good for in the UI, but not great for process, because in the process, to go into the processor process, execute like a thread, it takes time. For that, they have introduced a new concept called useRef hook. In React 18 and higher versions, they introduced a new hook called useReference. What is this is, it will create a memory reference. In that memory reference, you can store a value, and that value is meant not for presentation, it is meant for using inside the process. That means a process can easily read the data that is present in use ref. That means it is designed in such a way that process can easily identify. Process can use it fast. So remember, we can use a variable also, but variable is meant not only for process, it is meant for presentation. We have a specialized memory which is used only by process, and that memory they created in React 18, and we can design that by using what? Use ref. This memory is usually called as thread memory, which they don't need to show you, but they use internally. For example, I will show you. Suppose you have calculator. This is calculator. This calculator is an app. I hope you people know Windows is designed with which language? Windows operating system is designed with which language? VC++. That is the language used for Windows. All apps on Microsoft are VC++. Windows is built on a technology called .NET. Microsoft is built on .NET, and Windows apps are designed with VC++, Visual C++. That means Notepad, WordPad, MS Paint, Calculator, all these are VC++, Visual C++. Now observe carefully. In this, a language is used. In this now, I am doing some operation 10 plus 20, 30. If I ask you how many tasks currently this calculator is doing, how many tasks currently calculator is doing? I am using 10 plus 20 and result is 30. How many it is doing? Visually, you can see that it is doing some addition. It is handling two values. What is that? 10 and 20. It is handling a result called 30. But in the background, it is doing so many. If you want to see them, use Control Alt Delete. You will open Task Manager. Go to Task Manager. In the Task Manager, go to Details category. In the Details category, you will see Calculator app is running. What you have to do is right click on the column name, select columns. Make sure that in the columns you selected threads. This threads column you have to select. When you select threads column, you see now this calculator app is currently running 14 threads. That means 14 tasks it is doing. But visually I can see only one addition. But internally it is doing so many. And those are known to the person who developed it. The person who designed, he know what are those. That means for you it is showing only few, but internally it has to do so many. Calculator have to load, calculator have to allocate memory for buttons, calculator have to load events, button click event, equal calculation, so much work it has to do. Is it necessary to show you all? Not required. Just output is enough for you. That means what you see and what is used in the process are a little different. Some are meant for presentation, some are meant for process. Actually, earlier JavaScript people, not earlier, even now JavaScript people don't have a chance. They have to use same variable, var or let or what? Const. They have to use only these three for both presentation as well as process. But now in React, for presentation, different references, for process, different references. and we can create a memory which can be used for the process. How to create the memory for the process? Let's see how they designed the new concept. This will work, but this is not great. So what is the point now? Remove that reference. How to create a reference, memory reference, so that in that I can store something, but it is meant only for process. Then what you do is, in React 18 onwards, you can create a thread. I'm giving thread. You can give any name, A, B, C, X, Y, Z, any name. And it uses useRef hook. By default, useRef is null. Why null? Null means in JavaScript, what is difference between undefined and null? Already we learned data type. Na? Why null? Null because we are expecting a value at runtime. We are expecting a value at compile time, then we make it as what? Undefined. You know, na? At compile time, when value is not provided, then it is what? Undefined. At runtime, value is not there, that is null. Why it is null? Because the memory is allocated at runtime, the process is stored. So it uses null. Now what we have to do is, this thread, we need to assign this task, second task, to the thread. Then how do we assign is thread dot, we have to use thread dot current. Thread dot current. Current means it attaches this to current process. Current equal to, this function is loaded into the process. That means what this useRef can do is, it can create a process thread. In the thread, it can load your task. That means in the current thread, it is loading this task. Now what you can do, you can use it. Remember, whatever you stored in this useRef, it is very good for process, very fast for process. Process can easily understand. Process can easily access. If you store in a variable, process have to search for it. It will take some time. It will be slow. So this is easy. Now it is there. Okay. Now what we have to do, we have to kill this thread anytime. That means, you know, without closing calculator app, how to terminate it. You opened some apps on your PC. Without closing, how to terminate the apps? Without closing, how do you terminate the apps? Simple. What you do is, suppose I open calculator. Without closing, I should terminate. Without closing, I should terminate. Then you can go to Alt Control Delete, Task Manager. In the Task Manager, you can select which app? Calculator. Calculator app. You can right click, you can end task. You know, na? End task means it will kill that task. That means what you are doing, you are going into process and from there you are killing it. That means if you want to terminate any task, you need to kill it. Kill the task. Now let's see how do we kill the second task. That means second task, how do we kill this? We will put a button. And another button I am using class my4 and btn danger. And here I have bi volume mute something, volume off something, or volume mute. Okay, and this is 50%. Just roughly I'm giving that. Now what should happen is ms, okay, 2. Okay, some gap is there. Now what should happen when I click on this? The 50% volume should terminate. Only directly after 10, it should go to how much? 100. Understood? So actually, now when I click the volume up, it says 10%. After that, it will go to 50%. After that, it will go to 100. Now what we need to do is, before it releases 50, I want to cancel 50 from memory. I want to kill it from the memory. So we have to write here another option, that is function handle cancel click, or say we say mute click. On mute click, we have to kill the second thread. Then we have to use which function? Clear timeout. Clear timeout, where it is present in memory. It is present in thread. Thread dot what? Current. That means the current thread will be killed. And it should happen when you click this button. That means on click handle which one? Mute click. I'm using this. And remember, it will kill it only when you click the button. If you don't click the button, it will continue. So I click this button and I'm not clicking that mute, then it will work. 50% also will work. But what I am doing now, I click the volume. After that, I click the 50%. Then see what happens. After 10, 50 will not come. Directly 100 will come. The 50 is removed. Am I right? So that means you are removing the task from the memory. Remember, you should click the button before it is released. Once it is released, you can't cancel that. Right? Before it is released, you click, then it will be deleted. And how do you kill a thread? How you delete a thread from the memory? For that, we need what? We need a clear timeout. Clear timeout. So clear timeout, actually, it removes the task from the memory. Syntax, it needs like this here. Clear timeout, and it needs, so reference name, the memory reference name. So now here one major React use ref hook. What is this new hook and how do we handle this? So React 18 version, 18x version introduced a new hook, useRef. Introduced a new hook, useRef. It is used to configure a reference memory which is native to the process, It allocates memory and stores data so that it can be used by the process. The data in reference memory is not intended to present. It is intended to use in the background process. That is the point. Data in reference memory is not intended to present. Present means where? Present means in the UI. In the UI. It is intended to use in the background process. That is one important. Almost out of 100 React interviews you attend, 99 interviews have a question called what is useRef. There are so many like useRef, use memo. You will learn difference between them. Every React interview have a question called what is useRef. So syntactically, how you define, we have a reference. So this is some thread is equal to use ref and null. Thread dot current. Into that you can store any value or you can store any function also. As of now, what we are storing in it, we are storing a function. We can store a value also, some 10, 20, any type, primitive type, non-primitive type, or a function. You can store anything. But it is not meant for presentation. It is meant for what? It is not meant for presentation. It is meant for process. Right? Now, many times in interviews, they ask like, can I use it in presentation? You can use. You can use for presentation also, but it is not good for presentation. It is for what? Process. Just like, can I use a variable in process? You can use. You are using already. In various occasions, you are using variables in process because JavaScript don't have any special for that. Only three options are there now: var, let, and const. That means they are used in presentation as well as process. But here we have a clean classification for better performance, right? So now how do we do? So we need to use set timeout, and in that we have thread dot what? Current. Just syntactically I am showing here. So this is the mechanism called debouncing in JavaScript based applications. Debouncing is there in every technology, but in JavaScript we control debouncing by using this technique. We will create another example also. This is just a syntactical example. I showed you volume up, how to terminate any particular volume. So this is example. This is timeout demo dot what JSX. Let me copy this. This is timeout related example. Okay. This is the timeout concept. So that, and in this one new thing is we are using a hook called what? Use ref. Use ref is the hook. Okay. Next, let's see what is this interval. Set timeout, clear timeout. We saw one point. Examples we will put later. First we are learning what they are. This is not example. This is just a concept about it. We will implement in one example also. What is set interval, clear interval? What is the concept about interval? So timeout is for debouncing, and set interval. This set interval is used to control a concept called, this is called throttle. It is used to control a concept called throttle. Debouncing and throttle are very, very popular interview questions for any level of experience. These days, very common these are in interviews. Angular, React, everybody, these questions are very common. These two are very common. What is debouncing and what is throttle? What is meaning of throttle? Throttle is an English term. It's a normal English term only. It's not any technical thing. What is the meaning of throttle? Where you generally use this word throttle? Actual throttle concept is simple. You have a bike or a car, and you have a start button, right? When you push the start button, ignition ignites and the engine throttles. Engine throttles. What you say actually engine starter? After starting engine, what will happen? After starting engine, what will happen? Engine will throttle. You people may call engine is running. Where it is running? Engines don't run. Understood? Engines don't run. Engine is running. Engines don't run. Engines always throttle. Throttle means a sequence of operation repeatedly performed again and again, again and again, until a sequence of actions are performed again and again until you stop. Until you stop. That is called throttling. How to design these throttle tasks? These are all very common also. You see, best example is you see Amazon. Suppose you see, when you look at Amazon, like people Amazon, yeah. When you see Amazon have a sliding banner. Na? We generally call it as what? Carousel. Carousel. When page loads, carousel started. It will never stop. It throttles continuously. It never stops. It continuously throttles. You can manually control, but it will never stop. Manually control means you can go previous, you can go next, but it will never stop. Once it starts, it continues. One of the best example of throttle is this one. We can design like this. That means we can design this. That means a set of images continuously scrolling one after another until I stop. This mechanism is called throttling, right? So this we have to implement in our apps because so many such tasks we need. Once we start, it should continue. Until we stop, it should continue. Once I stop, it should stop. That is how actually media players, everyone work. What media player, suppose video, you are playing a video. So you are playing 30 seconds video. Suppose 1 second video. In 1 second video, do you know 1 second video may contain 30 frames? You know, when you are shooting a video, how to shoot a video high quality? Generally in your mobiles, when you shoot video in your camera settings, you will have 30 frames per second, 60 frames per second, am I right? If you increase frames per second, the quality increases. Obviously, size also increases. That means 30 frames one after another, it executes when you click play button. Until it reaches the end, it will repeat executing those one after another. The media player play button is throttling the frames. That means the song that you are listening is the result of a throttle. The video you are watching, that is the result of a throttle. A sequence of operations one after another immediately performed. Immediately you can delay time also. You can increase, decrease, na? You have the speed, na? That means 2x speed. That means video plays fast. 1x speed, it will be normal. That means you can control the throttles, right? That means you have a car or a bike, accelerator. What is that accelerator doing? Increasing, decreasing the throttle time. Throttle fast, throttle slow. That is the concept. Every web application, mobile application, all these have throttle mechanism. Let's see how to design this. Why you need this throttle? We will create like this carousels, auto control. We will create one slideshow like design. We will see how to do that, right? So actually what happens is, see, the concept of this interval also we will see with an example. Okay, let me clean this up. Okay, we have some heading, class margin top something. Okay, here we are having Here we are having a simple variable. In this variable we have now is equal to new date. It will store the current date, and we will have another variable time is equal to what? Now dot to local time string. We already learned time functions now. We already discussed about date time related one library. What is that library? Moment. To present date and time in a proper way, we have the library moment. Okay. Now we have a function called clock. This clock function have to set the time. That means we have console. We have a constant have timer. Suppose set timer is equal to use state, and in this what we do, set timer have time, and we will display the time here. That means just we are using the time. Timer we are displaying, and we will do one more work. Use effect at the time of mounting the application, this component, we will use clock. Clock is called, clock function is called. So the clock function is called. This function executes on load. Usually what is the point here is we are displaying a time, but this time is not ticking. It stopped. It is not ticking, it stopped. That means it is at 32 seconds. Why? Because at the time of mounting, we captured a time and we are printing the time. Then it will update again when it mount again. That means when I refresh this again, when I refresh this, then time changes. That means the time changes whenever I am refreshing. So that means at the mount, it executes once and it will stop. No, it should throttle. Throttle means what? Once it starts, it should not stop, continue. How you will make a function execute continuously? You can make a function execute continuously by using simple technique. You give this task to a set interval. Set interval. What is difference actually is timeout and interval difference is, see, what happens in timeout and what happens in interval. Suppose we are having 3 tasks. These 3 tasks will first load into memory. In timeout, what happens is the first task is removed from memory and it is sent into process. After it is completed, it is out of the process. Second task is into process and come out. Third task removed from memory, it is in the process. Finish. If I want them again, then again I have to load these tasks into memory now. But what interval will do is, it will keep the task in memory. It will release a copy of it into process. That means it is not deleted from memory. It is in the memory. A copy will come to process. It finished the process now. After finishing the process, after few seconds, this task again released into memory. From memory to process. That means it will repeat this again and again until it will repeat that again and again until it is removed from the memory. Am I right? This is throttling. Timeout doesn't throttle. What timeout will do? It will load the task into memory. From memory it will remove and it will send into process. What throttle will do? It will keep in the memory and release a copy into the process. Every few seconds a copy is released. It will continuously happen until you clean from the memory. That means you see now, I given this to interval, which one? Clock and 1000 milliseconds. Then what happens here is every second it has to execute. But you see it is not executing. Why it is not executing? Because again one problem is there in our declaration. What is the declaration you see? Where we declared this? We declared this outside. Outside means I told you now already, this is creation area. We have two areas na? Creation, another one is mount. You remember na? Set, we cannot set anything inside what? Creation area. So I will give here, but still it is not complete here. You see now it is having every few seconds it is flickering. Understood? You can see every few seconds it is flickering. But time is not updated. The time will update. We will do that. Because to update the time, we need to use these timer functions. What time functions we learned now? What are those? We learned moment library, Luxon library. I told you some libraries, na? Day.js, moment and all. They are required for designing that. Because date and time, it is two-way binding. One way, na? One way means it will just read and present. It will not allow to assign a new value. That assignment we will see how we can assign the new value. Actually, you see, we are defining the time. Directly, suppose if I am showing the time, that means we are directly defining the time. Means instead of timer, I am using the time variable here. Time is a variable. In the time variable, if you are doing this, means this globally I defined like, so that I can use this just roughly. And you don't need this now. This is globally available. I'm using the time. That means we are assigning some time and displaying the time. So when you run this, it is unable to execute because you know that what happens here. Usually the variables will not allow to assign. They are what? Immutable. Na? So what you need to do? We need mutable. For that, we need one more library to do that. What is the library you remembered? Which library? Moment.js. Moment.js is a JavaScript library for displaying, manipulating date and times in JavaScript. We discussed that. We will create one example for that, how to handle. So what is the total concept is interval. Interval is used. So it is used to handle throttle. It is used to handle throttle. Throttle is a mechanism of executing specified task, repeatedly until removed from memory. So it loads task into memory and releases a copy of task into process. Syntactically, what we do here also, set interval, it uses a function. In the function, interval you have to define. The function interval we need to configure. And we have how to clean it from the memory. For that we have what? Clear interval. It removes the task from memory that is loaded using interval. that is loaded using set interval. That is important. Syntax here same. Here it uses what? Clear interval. What is the clear interval? Reference name. Here also we can use useref. Here also we can use useref. Useref is used for reference name. Now we will design one example for this. We will create like carousel. You have seen Amazon carousel. It changes the slides every few seconds. Similarly, we will create our own carousel now. And for that we need interval. Interval will repeatedly perform the task. We will use API. We will get the data from API and we will display the data through the APIs and we will present it. That we'll see in tomorrow's session, right? In tomorrow's session, we are going to learn one real-time example with both options. One is timeout, another one interval. Tomorrow we'll do that. Okay, tomorrow's session, we will discuss about the concept of examples using debounce and throttle. Some examples I will show you how to handle. Okay, tomorrow we'll see. And 1 second. So for online and offline people, I will share a classroom code. You join because we have a new classroom code for people only attending. And remember, what I will do is every week I will remove and add the people again and again. Understood? So next week you are not attending the batch, you are gone from the classroom. Right? So every week I will do this. Right? Only people who attend the class, they will be in the classroom, otherwise no. Until end of the class I will do the same. Right? So the new class code you note down once. So for online people, I will share it separately. For offline people, first offline people, you copy this. Yep, this is the code. And join within 10 to 15 minutes immediately, because after that again we will change it. And don't share this with the people who are not attending the class. We will remove you from the class, we will keep them only. Understood? They will be benefited. You want to do a favor to them, then you sacrifice yourself. Don't share this with anybody, you will be removed from the class. And every few days I will change anyhow. Right? Because only people attending regularly, they will have this class code. Otherwise they don't. Okay. Okay, offline people, everyone done? Right. So then tomorrow we will continue. The same notes is same. All previous notes is available there. Huh? No? All is available there. Only the point is the code is changed now. Okay. Then tomorrow will continue. Right? Yeah. Online people I will share. For online people will share.